The real STEM, where the rubber meets the road. STEM is an acronym for science, technology, engineering, and math, processes used every day by the skilled crafts. Science, according to Merriam-Webster, is the state of knowing, knowledge as distinguished from ignorance or misunderstanding. Technology, again according to Merriam-Webster, is the practical application of knowledge, especially in a particular area, the collection of techniques, skills, methods, and processes used in the production of goods or services. The definition of engineering is the application of mathematics and scientific, economic, social, and practical knowledge in order to invent, innovate, design, build, maintain, research, and improve structures, machines, tools, systems, components, materials, processes, solutions, and organizations. Webster's definition of mathematics is the study of topics such as quantity, numbers, structure, space, and change. Algebra, arithmetic, calculus, geometry, and trigonometry are branches of mathematics, something we use every day. The real STEM is where the rubber meets the road, and it's taught every day in classes that we don't often talk about, like heating and air conditioning, industrial maintenance, millwright programs, manufacturing, process technology, industrial electricity. These are the real STEM programs. I'd like you to listen to some friends of mine tell you and show you exactly what STEM is.
I am Robert Stringham. I am a heating and air conditioning teacher, and I am science, technology, engineering, art, and math.
We are HVAC students, and we are STEM.
Real quick, and some of the things we're going to learn about, specifically this control board. Because for every input, there's an output, and it works and controls all these components in a sequence of operation. And the term I need you to remember for the sequence of operation is, take it slow, it's gonna blow. And not only that, but we have to size the gas line correctly for natural gas, because the combustion process down here that just engaged requires 1 cubic foot of gas for about 1,000 BTUs of heat that's rated on the nameplate. That's heating.
No, Stringham, that's science and technology.
Okay, Brian, I'm going to talk to you today about ventilation. We're going to take this flat piece of metal and using some measurements and parallel line development to fabricate an 8 by 8 inch duct to add to our classroom piece right here, as it's specified on these blueprints right here. Okay. This is ventilation.
This is no, Stringham. This is engineering and math, known as geometry.
Okay, Yusuf, I want to talk to you about this Hamden Variable Air Volume Trainer. And what it does is it uses this computer, which we program with a specific set point, to control this damper through this DDC board, direct digital control. This direct digital control will allow, depending on the temperature outside, fresh air to come into the building for free. This is commercial air conditioning.
No, Stringham, this is engineering and technology.
Okay, Troy, I want to talk to you about this compressor a little bit. When I remove this part here, you might remember it from level 1. What is that?
The head.
That's right, that's the head. And it exposes, when I remove it,
The valve plate.
the valve plate. And underneath the valve plate, you'll find 2
Pistons.
inside the,
Cylinder.
yeah, and the cylinder and pistons deal directly with Boyle's law. In other words, when you have, like in this one here, a lot of volume, that means the pressure is
Low.
low. And when I turn the pulley, that causes the piston to move up in the cylinder, which reduces the volume and
Gives you high pressure.
increases the pressure. Troy, this is air conditioning and refrigeration.
No, it's science, engineering, and math.
You got it. Okay. All right, Sven. I'm going to show you how to do a quick bending project that was actually part of the TNT contest that instructors had to do at the HVAC Excellent Conference this year that was down in Orlando. So I have a 3.5 inch mark, a 5.5 inch mark, a 4.5 inch mark, and then another 3 inch mark. And then what you're going to do is, we need to do 2 right angles and an offset with a 45. So the way we do that is we use this bender here. Now that we have our marks, place it in here like so. And I'm going to go ahead and start making my bends. So there's 190, and then we're going to continue on with another 90. And then we're going to do our offset, starting off with the first 45. And then we need to bring it back for the other 45. And this is copper tubing, used in air conditioning and refrigeration.
Oh, sure. This is like engineering. It sort of looks like art.
Okay, Caesar, this is a psychometric chart, and on it we can plot the course for our heating and air conditioning work that we're going to do. And there's some formulas that we need to use for that. In other words, Q is BTUs, sensible heat equals a constant, which is 1.08 times the volume of air we're going to move in cubic feet per minute times the difference in temperature that we want. This is the basis for heating and air conditioning.
No, Stram. That's math and engineering.
Very good. I am Robert Stringham. I am a heating and air conditioning teacher, and I am science, technology, engineering, art, and math.
We are HVAC students, and we are STEM.